Hi everyone, my name is Marian Novotny, and in this talk I'd like to present Siembol, an open source real-time security information and management systems based on open source big data technologies. Let me introduce myself. Currently I'm working as a software engineer at G Research, where I'm developing applications for security monitoring and intrusion detection. In past, I worked as specialized software engineer at ESET, where I was responsible for designing and implementing network intrusion detection systems that were integrated into various ESET products. I did some research in security at the university, where I focused on analyzing and designing security protocols. When I joined G Research, the team used Splunk for security monitoring. That worked quite well. But because of the expensive license, the team decided to build a custom security data platform based on open source technologies. And they chose Apache Metron as a core component of the platform. We started implementing missing features and plugins in Metron projects, but we soon recognized the limits and instabilities of Apache Metron, mainly in configuration management. We decided to start implement custom data processing framework in order to replace Metron. But transition was not so easy, and we used to live a long time together with Metron and replace component by component. When Metron was moved to Apache Attic, at the same time, we decommissioned Metron internally, and this brings the opportunity for Siembol projects to become an open source alternative for SIEM tools. And after writing documentation and maturing the code base, we decided to open source the project and contribute back to the community. We followed data pipelines from Apache Metron project, but we added components for alerting and incident response, which were missing in Metron architecture. The log after injection is normalized by a parsing application. It's normalized to flat JSON with common fields such as timestamp, host, or URL. The event can be enriched by an enrichment component from tables based on rules. For example, we can enrich an IP address by a DNS name or an asset by classification. The events are evaluated by alerting component, and alerts can be correlated with others in a correlation alerting engine. The escalated alerts are handled by response component that can integrate Siembol with tools used for handling response to the incident. I consider Siembol UI as the biggest improvement over Apache Metron. If you would like to scale to thousands of configurations, we need to have a configuration management interface with clean separation of duties and auditability of changes. It should support validation and testing configurations before they are deployed into production. This is a screenshot of the Siembol UI landing page. The list of services on the left panel is based on user authorization and permissions. Multiple service instances of the same type can be used by different teams and users in a single Siembol UI deployment. We distinguish between store and deployment of configuration. In the store, the user can edit and save configurations without deploying it. A Git repository is used for storing configurations, and all changes are committed by UI under a user as a committer. This way, we have clean, auditable history of changes. At some point, the user can promote the change and deploy the configurations, which creates a pull request in GitHub repository. After reviewing and matching the configuration, is released to Siembol components. The configurations are stored in JSON form and are edited by web forms. This allows us to edit the complex configuration, and moreover, it provides validation in order to avoid error and mistakes. Siembol UI supports testing configurations and creating persistent test cases that are stored in the Git repository. The test cases includes input for testing the configurations, along with assertions that should pass during evaluations. This can help to mitigate errors in the configurations, which can be possible changed by someone else than the former author. Siembol UI using Git for storing configurations. All configurations are edited by web forms and stored as JSON files. Siembol UI supports both OEDC, authentication and authorization. And authorization for a service is based on user group membership. Siembol UI supports high integrity use cases. It creates pull requests during deploying of configuration. The pull request can be reviewed before it's merged and released to Siembol components. When we implemented the parser in Metron, it was required for us to write Java code, compiled, test, and release it in production. This process can take time and can be error prone. This way, we decided to build a custom parsing framework in order to speed up onboarding a new data source. Parser is created and edited in Siembol UI, similar to other configurations. First, a log is parsed by a basic parser, such as syslog. We are supported with generic parser, syslog, and Metflow version 9. Then, a chain of extractors is executed in order to extract important fields, such as timestamp or host or URL. Finally, the fields are cleaned by transformations, where we can normalize values for fields, we can rename fields or filter them, or we can filter the whole message if it's not needed in further processing. This is an example of a simple parser for parsing AWS CloudTrail log. And as you can see, a JSON extractor is applied on the field original string, and timestamp is parsed from timestamp field or event time. In transformation, we are deleting fields that are starting with string request parameters resource. A parser can be integrated in a single application or can be combined with other parsers in a router parsing application in order to speed up onboarding a new data source. The parser is selected based on the routing field, and this allows us to maintain big applications that collects logs from multiple data sources, which, as example, can be a syslog or nxlog data source. Metron used HBase for storing enrichment tables. We had issues with the stability and performance of HBase tables implementation in Apache Metron. And we decided to use only in-memory tables that are sufficient for our use cases. The tables can be stored in HDFS, but we are also supporting HTTP store, and currently we are moving to HTTP in Kubernetes deployment in order to simplify deployment of tables. Enrichments are defined in rules that are edited in Siembol UI, similar to other configurations. This is an example of a simple enrichment rule. And in this rule, we are enriching an IP address by a domain name. And the rule is applied after matching the field IP DST address, and the table with name DNS is joined with event using the IP address as a key. If the table contains the IP address, then the event is enriched by the field DNS name. Metron has no dedicated component for alert escalation, and this feature was required by our SOC team. This way, we decided to build a custom framework for real-time stream evaluation of detection rules without the need to index events. This approach allows us to scale to thousands of detection rules that could be problematic in a solution with storing and querying data. This is an example of alerting rule. Siembol alerts are edited in Siembol UI, similar to other configurations. And in this example of AWS file authentication, we are matching field event name with the string console login and field error message with the string failed authentication. We are adding tag correlation key with field that is stored in user identity principal ID field. Siembol alert can be escalated directly to the Siembol response component, or it can be used for correlation with other alerts in correlation alerting engine. This engine allows us to combine alerts from various data sources, and also it allows describe complex threats and complex attack scenarios. Correlation alerting rule is defined in Siembol UI, similar to other rules. And in this example of brute force AWS logins rule, we are correlating AWS failed authentication alerts in 1 minute time windows, and the thresholds for triggering the rule is set to 10. Siembol UI supports importing the Sigma rule into Siembol alerting engine. Supporting open standard formats for SIEM detection rule is more efficient, in our opinion, because the rules created by community can be easily imported into Siembol alerting using Siembol UI. This is a screenshot of Sigma importer dialog, and as you can see on the left side, you can define the field mapping from Sigma rules to Siembol rule, and then you can copy Sigma rule. And as you can see, Sigma rule is in YAML format, and Siembol format of Siembol alerting rules is in JSON, and it's edited using the web forms. So we consider JSON with web forms as less error prone than editing YAML files. After clicking import, the rule is imported into Siembol alerting, and you can modify and tune the rule if needed. You can add a test case in order to improve the quality of the rule. Siembol Response is a component for handling a response to an alert escalated by Siembol alerting components. It's used for integrating Siembol with systems used for handling incident response. In a rule defined in Siembol UI, SOC team can automate their incident response by enriching alerts, by doing additional ELK, LDAP, or virus searches, which are defined in Siembol Response rules. Siembol Response allows filtering alerts in this stage based on rules. Escalated incidents can be created in internal systems such as Jira or the Hive. The Siembol Response has a plugin architecture that allows the implementation of custom integration with internal systems if necessary. The plugins are also integrated in Siembol UI, so you can use Siembol UI to edit and test Siembol Response tools using evaluators from custom plugins. Siembol architecture was designed in aim to allow us to scale with the number of events and configurations and quickly adapt to changes in technologies. So this is a follow picture of Siembol components. We try to decouple components if possible. Siembol UI adapts microservice architecture, where a single pay application is developed in Angular and the REST API in Java Spring Boot. Siembol UI is using identity provider for authentication and authorization using standard OAuth2 OpenID Connect protocol. It's using GitHub for storing configurations and managing pull requests. Siembol REST adapts the modular architecture. In order to validate and test configurations, it includes the same modules which are included in Siembol Storm applications. One exception is Siembol Response with microservice architecture. Siembol REST API is using HTTP calls for testing and validating configurations because Siembol Response loads plugins, and we would like to avoid loading plugins in multiple components. Siembol adapts desired state pattern to release storm topologies. The desired state is computed by Siembol REST from Git configurations, and it's synchronized using Zookeeper. And Storm Topology Manager kills and starts topologies based on the state. Storm Topology Manager is deployed on Kubernetes, but Storm Cluster doesn't require to be deployed on Kubernetes. Our initial deployment was with external Storm Cluster that was orchestrated by Storm Topology Manager from Kubernetes. Siembol can be deployed in an external Storm cluster and orchestrated from Kubernetes using Storm Topology Manager component, and it was our initial deployment. However, we prepared a Helm chart for Storm deployment, and currently we are moving to Kubernetes deployment with Storm internally. Siembol REST computes desired state of Siembol topologies from configurations that are stored in Git repositories. The state is published in Zookeeper and consumed by Storm Topology Manager. The manager uses API of Storm UI to kill topology or launch Kubernetes jobs in order to start a new topology. The jobs are using Docker images with Storm CLI, Siembol jar files, and arguments for the topology are encoded as base64 string and are passed into the main function during topology initialization. The topology is built pragmatically in the main function. We used open source Bitnami charts for Zookeeper, and we prepared and published Helm charts for Storm. The Storm state is stored in Zookeeper, except internal data stored by Nimbus, such as jar files of topologies and metrics of topologies. This way, only Nimbus is defined as a stateful set, in contrast to Storm UI and supervisor that are defined as deployments. And workers are launched in supervisor deployment, and this way we can easily scale up the number of replicas in supervisor deployment if needed. In Siembol, we are using our two OpenID Connect for authentication and authorization with standard scopes such as email and groups that are used in Siembol REST. And Siembol UI supports all two OEDC authentication natively, and configurator REST is a resource server that verifies JSON web tokens, which are issued by an identity provider, and Siembol UI or configurator UI initiate code flow with identity provider in order to obtain a token, and is using token in calls to configurator REST API. On the other hand, we needed to integrate a Storm UI in Siembol that it doesn't support OAuth2 protocol, and this way we are using open source tool OAuth2 proxy, and in combination with Nginx or through OAuth ingress annotation. We can use OAuth OEDC protocol also for Storm UI and other services. They are not they don't support natively OAuth protocol. Siembol CI/CD pipelines on public GitHub repository are building 7 Docker images. 3 of them are Storm applications. 3 of them are Spring Boot applications, and 1 single-page applications developed in Angular. Moreover, CI/CD pipelines publishing Java artifacts into a central Maven, and we are publishing Helm charts for Siembol and Apache Storm. Siembol can be used as a SIEM tool using open source big data technologies, or can be used as detection tools for detecting leaks and attacks on infrastructure. Moreover, we are supporting Sigma rule evaluation, so Siembol can be used as Sigma rule evaluator without need of index logs. So internally at GR, we are using Siembol as SIEM tool, and Siembol architecture allows processing 250,000 events per second, which means 20 billion events per day, and means 15 terabyte raw of data. We are onboarding 90 data sources and evaluate around 300 detection rules. The rules were released 750 times with auditable Git history of each release. This is computed and executed in 27 Storm applications, and we believe that Siembol architecture allows us to scale up the number of events and number of configurations. At GR, we are using Siembol as a detection tool. Big data team is using Siembol for detecting leaks on HDFS files that are transferred between zones, and Siembol can replace expensive tools, and moreover can be used for detecting leaks on other platforms. And let me know that we are supporting Sigma rule importing, and this way the team can easily import Sigma rules which are created by community if needed. We open sourced Siembol in April this year, and I would like to share my personal opinions about benefits of developing an open source project. Developing an open source project is changing your mindset of developing. You starting to reuse open source packages, tools, and standards, and you try to decouple with proprietary software and reliance on vendors. This approach, using open source standards, can improve efficiency. For example, using Sigma rules specification can save time to create detection rule, or using standards for authentication and authorization can also save time with integration with other systems and tools. Moreover, if you are developing open source tools, you need to learn how to separate confidential company sensitive data with code, and this allows you to develop outside internal network, and this way you can easily integrate available tools such as dependable code QL. And moving to Kubernetes allows you to have much more flexible deployments and easily scale computational resources or move to different data centers. Moreover, upgrading versions of dependencies can become much faster and easier. If you like to regularly upgrade your dependencies, you need to improve your testing if you don't want to test manually, and in order to spot issues after upgrade. And so this way you need to invest your time to improve tools and processes related to automatic testing. On the other hand, keeping your dependencies up to date allows you to use new features. You can mitigate vulnerabilities and bugs that are fixed in recent versions. Developing open source projects, motivation to improve code quality because other people can watch at your code, and also it improves documentation because other people can use your project. And be visible and open for feedback allows us to compare a Siembol project with a similar solution and discuss issues and requirements that helps better understand domain. Moreover, we are starting contributing back to community with technologies and tools that we are using in the project. We prepared and published Helm chart for Apache Storm that we are using in our Kubernetes deployment. We implemented Sigma rules importer in Siembol UI, and this way Siembol can be used for real-time Sigma rules evaluation that doesn't require to index logs. Moreover, we recently prepared pull requests for upgrading Docker image with new version of Storm, which was released recently, a few weeks ago. Requirements for project like Siembol are always changing because the world is changing, threats are changing, and technologies are changing. For example, you need to process a high volume of logs because of moving to new data centers or new applications that generate more traffic. You need to parse a specific format of logs, or you need to able to detect a specific attack scenario or specific threats. Keeping dependencies up to date and using standard tools for CI/CD and deployments allows the developers to quickly adapt for changes, in my opinion. So our example in Siembol, we are moving with infrastructure dependencies such as Zookeeper and Storm to Kubernetes, and this allows us to use new version of these dependencies, and, and we can easily move also with the default language that is supported in a new version of dependencies. For example, Apache Storm 2.3 has been released a few weeks ago, and we built Docker image internally, and after testing, we immediately recognize few improvements and bug fixes, so which are very useful for us. So we decided to move to new version, and we need to wait for official Docker image, but we prepared pull request in official Storm Docker repository, and so far we are using our internal build. If you would like to try Siembol, we prepared a quick start guide with a simple deployment on Minikube, with a Git repository with Siembol configurations for this demo. In this demo, the Siembol is in disabled authentication mode, but we are working on a version with enabled authentication using common identity providers. Later, we would like to also prepare a proper cloud testing deployment. If you decide to try Start Try, feel free to discuss issues, provide feedback for us, or just ask for help using GitHub discussions from slides. Siembol is not a one-man project, and I would like to thanks to all Siembol contributors. If you are interested in the project, please visit our webpage siembol.io, or have a look at Siembol GitHub repository gresearch/Siembol. So thank you for your attention and enjoy the rest of the conference.